Among the servicing operations in the car sector, overhauling the gearbox has always been an operation which requires care and precision. The modernity of the 33 is the confirmation of its design, which has been fine-tuned during tested and proven productive experience. As the engines have been developed and diversified, so the gearbox has been adapted to the different power potentials. Its removal from the car does not involve particular directions. These may be referred to in our publications where the subject is dealt with appropriately. This description will be limited to strictly maintenance operations in the following order. Rods and forks, disassembling, checking and testing, reassembling, shafts and gears, disassembling, checking and testing, reassembling, differential gearing, disassembling, checking and testing, reassembling, supports, disassembling, checking and testing, reassembling, rods and forks. Operations concerning the gear selection and engagement system can be carried out under the body without removing the gearbox. We are going to carry out these operations on the bench for illustrative purposes, but the procedure remains the same. Disassembling. We start by removing the electromagnetic coupling, if the model is fitted with one. Then the oil sump and the tachometric sensor are removed. Then we remove the rod that positions the gear selection and engagement rod return spring. Before removing the rods, the screws fastening them to the forks are removed. Followed by the first and second gear control lever. Before taking off the selection rod, the case containing the spring and the ball that positions the engagement rod should be slackened and removed. The reverse gear safety lever pin is brought on level using a special tool. And the same tool is used to remove the pin fastening the selector. Moving on to the fifth reverse gear rod, the pin fastening the lever to the rod is removed. Then the selection lever is removed, recovering the selector, the spring, and the reverse gear safety lever. To remove the fifth gear and reverse rod, fifth gear is engaged, and the check ring on its end is taken off. After removing the plug, the spring and the two balls below are recovered. Now the fifth gear and reverse rod with its fork can be removed. Care should be taken in saving the positioning pawl, which is pushed by a spring. Once the third, fourth, and first, second rods have been taken out, the corresponding forks can be recovered. Here too, the positioning pawls and springs should be saved. Once the side plug has been removed, the two safety system pawls and the connection pawl inside the rod can be recovered. Checking and testing. The components should be washed thoroughly and examined for surface defects and their state of wear. Particular care should be given to checking the state of wear on the forks and that they are not distorted. The rods and the hollows machined on them should be checked for distortion, scratches or wear. The positioning and safety pawls must not be scratched or show signs of seizing. The flexible pins, springs and fastening screws should always be changed. Reassembling. The forks for the first, second, third, fourth gears are positioned on the sleeves. The two safety pawls are greased and inserted in the horizontal housing using special tools. A rod tool is inserted in the housing for the third, fourth rod, and a new spring with the corresponding pawl is positioned through the hole in the tool. With the tool used previously, these are pressed to allow the removal of the auxiliary rod and insert the control rod. When the opening for the screw on the rod corresponds with the hole on the fork, the pawl can fit into its housing without turning the rod. Once the safety pawl has been fitted in the first, second rod by the procedure followed previously, the spring, pawl and rod are positioned. After a similar procedure, the control lever and the corresponding engagement sleeve are fitted on the fifth reverse rod. Then the threaded plug is repositioned on the horizontal hole. After aligning the hole centers, the control lever connection pin is inserted in the fifth reverse rod. The balls, together with the corresponding springs, are fitted in their housings. And the threaded plug is locked and then slackened 1/4 of a turn. Subsequently, the plug should be corked. The stop ring is then positioned on the end of the 5th gear shaft. Once the selector rod has been inserted, the safety clip, spring and selector are fitted on it, inserting the connection pins using the tool employed previously. The safety lever pin must be inserted, leaving a few millimeters projecting, while the gear selector pin should be inserted completely. After introducing the ball and spring in the gear engagement device, the plug is tightened to the specified torque and corked. Then the auxiliary stop rod is positioned and the 3rd, 4th gear fork is centered on the sleeve. The 1st, 2nd gear lever is positioned. A 1 mm gap is left between the 3rd, 4th rod and the 1st, 2nd control lever. Then the 1st, 2nd gear fork is centered on the sleeve, and all the screws are tightened to the specified torque. Reference should be made to our publications for all the tightening torques to be adhered to during gearbox overhauling operations. Lastly, the rear cover, or the electromagnetic coupling, is fitted on the cars which have one. The splash guard for the gear selector rod is inserted using a special tool. The sump is refitted, and the oil is topped up to the specified level. Shafts and gears. Disassembling. When disassembling the gear system, firstly, the driven shaft has to be removed. First of all, this involves removing the supports of the differential outlet shafts with their spacers. Once the supports have been taken off, the differential carrier can be removed. Shifting the sleeves, 2 gears are engaged to obtain the required resisting torque. Once the corking has been removed, the nut can be taken off. In preparation for the next operation, the transmission shaft head screw is slackened. The 5th gear hub and gear, complete with bush and bearing, are removed. Then we go to the front of the shaft. To recover the whole assembly of rotary and engagement components. Care must be taken to mark the order and position of the bushes and gears, which must be followed when reassembling. After removing the transversal lock screw of the reverse gear shaft, the shaft, fork and idle gear are taken off. The transmission shaft can now be disassembled. After removing the springs, the pins are removed. And then the front shaft and the sleeve are removed. The head screw, slackened previously, is now removed with the corresponding oil carrier. Using a tool, the fifth gear driving gear and the associated spline are removed. Operations continue, taking off the front bearing transversal lock screw. After having removed the Seeger ring on the rear bearing, the driven shaft is put back in place, also repositioning the inner part of the bearing. To remove the fourth speed gear, a tool is assembled made from a fork-shaped section and a section that is locked by the shaft nut. Another tool, complete with end piece, is fitted on the box, and when the screw is turned, the transmission shaft is pushed forwards until it is taken off the gear. Also removing the front bearing. The tools are removed. The driven shaft and the inner part of the rear bearing are pulled out, and the gear is recovered. A slotted plate is inserted and the transmission shaft bearing is removed. The tool is disassembled and the shaft is pulled out. Lastly, the same tool is reassembled in correspondence with the axis of the driven shaft. Using a plug fitting and a slotted plate, the rear bearing outer ring is removed. And with the help of another fitting, the inner ring of the other bearing is removed. Now we can move over to the front section of the gearbox. Having removed the Seeger ring from the clutch thrust bearing, the control lever fulcrum pin can be taken off. Then, the splash guard for the front shaft is taken off. With the corresponding bush. If during a different operative procedure, the splash guard needs to be removed with the front shaft assembled, this can be done using another special tool. Still using special tools on a vice clamp, the driven shaft bearing is removed, recovering the spacer. The gearboxes fitted on 16-valve engines have been adapted to the increased amount of power available by increasing the axial length of the toothings. To obtain these higher dimensions, the third speed gear has been inserted on the transmission shaft by grooved coupling rather than a solid one. Checking and testing. After disassembly, the pieces are washed thoroughly. They should then undergo a careful site check for any surface defects. Any parts that are not in perfect condition should be changed. The synchronizing device is disassembled by removing the rubber ring. The component should be checked for surface wear, paying special attention to the surfaces of the synchronizer rings and to the outer surfaces of the stop bands. During reassembly, particular care should be given when positioning the first gear stop band, which in this case is a single one. It is also important to check that the sleeves slide freely on their hubs. The gear teeth should also be checked, paying special attention to the sleeve teeth and to the side teeth. If the teeth are found to be worn unevenly or indented, the gears with which they mesh should be checked for damage. The bushes should also be examined. These should not have any scratches, cracks or signs of seizing. The inner surfaces of the gears should also be checked. The bearings should be carefully examined, turning them slowly. If the bearing is in good condition, it should roll smoothly without jamming. Also, the turning parts and rings should be carefully inspected. These must not be scored or show signs of abrasion or overheating. The splash guard, the driven shaft nut, and the transmission head screw must all be changed. If the synchronizer rings need changing, after assembly it should be checked that the synchronizer turns freely in its housing. If the pinion shaft needs to be changed, the crown wheel that meshes with it must also be changed. Reassembling. This starts by repositioning the transmission shaft until there is sufficient space to introduce the 4th speed gear. Then, the shaft is fitted in the gear. The shaft is moved backwards, and a tool with a fitting is assembled to insert the bearing. Once the Seeger ring has been fitted, still using the tool, the shaft is inserted in the bearing. Then the front bearing is inserted and fastened by the special screw, which must be housed in the locking notch provided on the outer race. After fitting the bush that concerns the front shaft and the corresponding splash guard, the thrust bearing support is assembled with the corresponding Seeger ring. The clutch control lever fulcrum pin is then fitted. Now, the front shaft can be inserted in the coupling sleeve, positioning the pins and springs. Using a tool fitted with a plug fitting, the rear bearing outer ring is inserted. The front bearing outer ring is also fitted using another accessory. The operating conditions of the bearings are strictly related to the loading rate by which the operating pressures are determined when the head nut is tightened. These pressures must correspond to the values experimented previously. The procedure to be followed is this. A pinion tool is inserted with the front bearing inner ring fitted, and the nut is tightened on its end after having fitted the rear bearing inner ring. A support is fitted on the nut, and a 100mm radius disc is placed on the support. A metal wire is wrapped around the disc with an end piece, on which different weights, which depend on whether new or old bearings have been fitted, can be loaded. Two different ranges of weights must be used for the two different situations. These are described in our publications. Turning the disc, the dummy pinion is locked. The nut is tightened and a few turns should be made to settle the assembly. Then the weights are applied, chosen from the appropriate range, which of course has a minimum and a maximum. When the disc is locked after applying the maximum weight, it should be slackened, and an intermediate weight should be found that makes the disc move downwards at an even speed. Before positioning the driven shaft, the thickness of the ring between the pinion and the bearing should be determined. In order to obtain correct meshing with the differential crown gear. Incorrect meshing would of course cause noise and wear of the bevel gear pair. The thickness varies depending on the dimension according to which the machine parts have been made in production, and according to how the departures are combined in relation to the nominal values. Here too, a precise procedure should be followed. A gauge is inserted in the housing of a side support and is fastened by screws tightened to a specified torque. Then, using another gauge, a dial gauge fitted on a suitably shaped support is set to 0. The support with the dial gauge is rested against the head of the pinion tool, and the departure value is measured. The measurement should be repeated, inserting the tool in the housing of the opposite support. If the resulting departure value, S1, differs from the second one, S2, their mean value should be calculated. The formula for this is S equals S1 plus S2 divided by 2. And the values are expressed in 1/100ths of a millimeter. This value is connected with the precision machining level of the casing, which must be combined with the precision machining level of the bevel gear pair. Relating to this, a particular value in 1/100ths of a millimeter for each pair is stamped on the bevel gear shaft. For example, if the result is S equals S1 plus S2 divided by 2 equals 80/100ths, placing a spacer of this value between the pinion and the bearing, the reference will only refer to the casing machining. But if, for example, the printing on the shaft is +6, this means the dimension AB must be increased by 6/100ths to optimize the coupling between the crown gear and pinion. Therefore, the spacer must be decreased to 74/100ths. Conversely, if a negative value is printed on the shaft, -8 for example, in order to decrease the AB dimension, the spacer should be increased by a corresponding value to 88 hundredths. Once the size has been established, the spacer is chosen from a range available in 5 1/100th steps. Then, the inner part of the bearing is also positioned on the shaft in the vise. Reassembling continues, repositioning the reverse gear unit fastening the pin with the special screw. The driven shaft is inserted and the gears are fitted on it in the correct order. Now, a 9.6mm reference spacer is fitted. The rear bearing inner ring is repositioned, and assembly of the driven gears is completed. The nut is tightened to a specified value using a torque wrench. A tool with a dial gauge is fitted on the casing to measure the clearance. This will be determined by the sum of the departures of the measurements of the gear assembly components in relation to the nominal values. The clearance is eliminated by reducing the height of the spacer inserted previously. The height of the replacement spacer should be calculated by subtracting from the 9.6mm height of the reference spacer. The clearance value measured with the dial gauge minus another 1/10 of a millimetre. The further 1/10 of a millimetre subtracted compensates for settlements in the positions of the components of the gear assembly, which take place during their operation. Once the size of the spacer has been calculated, it will then be chosen from a range of spacers available with 5 1/100th intervals. After disassembling the 5th gear unit and the reference spacer, a spacer of the calculated height is inserted. When the 5th speed driving gear and the corresponding screw have been fitted on the transmission shaft, assembly is completed by refitting the driven assembly on the driven shaft. Applying the torque specified for both shafts using a torque wrench. With the disc and cable used previously, loaded with the weight found to be most suitable in the simmer operation earlier, the load should move downwards continuously at a low speed. If this is not so, the spacer should be changed by trial and error. Differential gearing. Disassembling. The differential gearing was removed previously from the casing in order to remove the driven shaft. After backing off the screws, the crown gear is released, and a tool is used to detach the bearing inner races. Then the lock rings are taken off, and the planetary gear pin is taken out. The planetary gears are turned by 90 degrees and extracted through the side openings. With the planetary gears, the other components are removed. They're rest spacers, the crown wheels, and needle bearings, with the corresponding spacer. Checking and testing. The components are washed thoroughly before examining them carefully. The surfaces of the rotary components and of the rolling rings should be checked for signs of wear or traces of overheating. The bearings should also be turned slowly to check that they do not jam. The gear teeth must be inspected for scratches or signs of abrasion due to uneven coupling. The condition of the carrier is inspected, checking the resting planes of the crown wheels and planetary gears. It is also wise to check the condition of the resting surface of the crown gear. Lastly, the planetary gear shaft should be inspected and its coupling condition. Reassembling. Assembly of the bevel gear involves accurate cleaning of the resting surfaces. The fastening screws must be replaced by new ones, as these are coated with the self-locking product which only works the first time they are tightened. The screws should be tightened in diagonal order to the specified torque. The remaining reassembly operation consists of reversing the order of the operations followed for disassembly. Adjustment of the position of the gear assembly components is entrusted to the experience of the mechanic, who keeps the planetary gear still and turns the crown gear to check the backlash between the teeth, changing the spacer under the bearings if necessary to eliminate any slack or forced mating. The round washers under the planetary gears must always be replaced by new ones. Reassembly is completed with the bearings. Supports. Disassembly. The side supports too were disassembled previously in order to remove the driven shaft. The bearing ring nut and the phonic wheel, connected to the speedometer fitted on the right-hand shaft, are inserted with a considerable amount of interference. To remove them, a tool is needed which is screwed onto the outer threading of the ring nut. The shaft is released from the bearing under a vice clamp. Then another tool is used to remove the upper bearing outer race. After removing the stop ring, the splash guard and lower bearing are removed. Lastly, the outer seal ring should be removed. Checking and testing. When the support has been disassembled completely, the components are washed thoroughly. The bearings are turned slowly to check that they do not jam. The spline teeth of the shafts must not be scored or show signs of wear. If any defects are found, the parts with which the components involved mate should be checked for damage. The splash guard, the outer seal ring, and the lock nut should always be changed. Reassembling. The reassembly operation begins by inserting the splash guard. Then the bearing with its Sieger ring is fitted. This is followed by the taper bearing outer race. And the shaft. The surfaces are lubricated before inserting the lock nut and the phonic wheel. Then the outer seal ring is fitted. After inserting the differential carrier in the gear casing, the two side supports are fitted. On the side opposite the ring gear, a 1.5mm high spacer is inserted, and the screws are tightened to the specified torque. On the ring gear side, the support is positioned nearer. The screws are tightened by hand until the end float of the differential carrier has been eliminated. Now the height of the spacer on the ring gear side should be determined. Calling the first spacer A, the spacer to be calculated can be called B. The gap relating to B is measured at 4 points, using a spacer gauge. The mean value of the 4 measurements is decreased by 20 hundredths, and a spacer of this height is inserted, which is chosen from a range available at 2.5 hundredth intervals. The screws are then tightened to the specified torque. Mating between the ring gear and pinion is checked by locking the pinion. Then a dial gauge is used, resting the feeler on the outer end of the tooth, perpendicular to the side. The measurement is repeated 4 times in 4 positions, 90 degrees apart. The mean value of the 4 clearances must be between 8 and 13 hundredths. Correction is made by changing the height of the spacers. If the clearance needs to be increased, spacer A is increased and B is decreased accordingly. Conversely, if the clearance needs to be decreased, spacer B is increased and A is decreased. Due to the geometry of the teeth, to change the dial gauge reading by 1/100th, the height of the spacers must be moved from one side to the other by 1.5 hundredths. For example, if the clearance needs to be increased by 4 hundredths, spacer A should be increased by 6 hundredths and spacer B should be decreased by 6 hundredths. To conclude, we should also like to mention that servicing operations on the gears, shafts and operations for changing the differential ring gear involve disassembling the rods and fork system, which must necessarily be reassembled as described in the first paragraph. The tightening torques and all the other values entailed in the operating conditions of the gearbox are to be found in the workshop manual. The technical bulletins provide information on all revisions of operating procedures. The part numbers for the tools are given on the specific microfiches, as well as in the workshop manual.